Okay, 7.1 is multiplying monomials. When you have a product of powers property, that states that if you are multiplying two variables, you add the exponents. And I should say the variables have to be the same base. Example, b to the third times b to the seventh is b to the 10th. G to the fourth times g to the seventh is g to the 11th. Example 2, that's a 6. 6, we're going to multiply our coefficients together. 6 times 2 is 12. N to the third times n to the second, we multiply our variables together, and we add the exponents and get n to the 10th. Example B, we're going to multiply our numbers together. Now, it might not show the number in front of b to the third. You can put a 1 there if you'd like. Multiply 3 times 1 is 3. We're going to multiply our p's together. This does not have an exponent. It's understood to be a 1. So we add the exponents. P to the 1 power times p to the third is p to the fourth. T to the third times t to the fourth is t to the seventh. In example 2c, to multiply these two monomials together, we're going to multiply our coefficients. Negative 4 times a negative 6 is a positive 24. Now, we're going to multiply our r's together. R times r to the fifth, again we're going to add and get r to the sixth. This is understood to be a 1. X to the second times x to the second is x to the fourth. This is a y, sorry. Y to the third times y is y to the fourth. Power of a product property. When we have a power, I also call it a power of a power, we multiply the exponents. So that's b to the 15th, g to the 42nd. Example 3, this is a power of a power of a power, where our base is 2. What I recommend doing is carrying the base and then multiplying all the exponents. 3 times 2 is 6. 6 times 2 is 24. Now that's 2 to the 24th power. That is a large enough exponent that I am okay with you leaving it like that. You don't have a calculator, which I don't even have a calculator with me right now, so I can't even calculate it. So example B, I'm going to leave the base of 2, and again, I'm going to multiply the two exponents. 2 times 2 is 4, and 4 times 4 is 16. Okay, example 3. Again, I'm going to keep the base, and then I'm going to multiply the exponents. 2 times 3 is 6. 6 times 2 is 12. Now this time, the power of a product property, if we have two bases, we have to multiply each exponent. So this is a to the 1 power and a b to the 1 power, so we multiply and get a to the m, b to the m. Example, that's negative 2 to the 5th power. This I am thinking in my head. Negative 2 to the 5th power is a negative 32. Remember, if your exponent is a negative exponent, if your exponent is an odd, then your answer is going to be negative. If your exponent is even, then your answer will be positive. Now we have a power of a power, so that's x to the 5th, y to the 15th. In this example, everything is to the 4th power. At first, that's negative 3 to the 4th power. That is saying negative 3 to the 4th power. We should be able to mentally do that in our head. Because the exponent is an even exponent, my answer is positive. 3 to the 4th power, that's 3 times 3 times 3 times 3 is 81. Power of a power, we multiply, that's x to the 4th. y to the 8th, and z to the 16th. Okay, example 5. The very first parentheses does not have an exponent outside, so we don't have to do anything. But the second parentheses is a power of a power. The base is negative 2y. So I could do this one of two ways. I can write the base and then multiply the two exponents and get 6. Now I'm just going to bring down the first parentheses, but I'm going to replace the parentheses with the dot. Now, go back to the second parentheses. I now have to do everything in that base to the 6th power. Negative 2 to the 6th power, because 6 is a positive exponent, an even exponent, the answer is positive. 2 to the 6th power is a positive 64, y to the 6th. Okay, now I'm going to bring down the 3x, y to the 4th again. Now I'm ready to multiply my whole numbers together, my coefficients. 3 times 64 is 192. I don't have anything to multiply the x with, so I'm going to bring it down. And y to the 4th times y to the 6th is y to the 10th. Example B, I have the very first parentheses is to the 3rd power. Now that's a fraction. That is, I have to cube 1 and I have to cube 2. Or think of it as 1/2 times 1/2 times 1/2, which is 1/8. Again, I have a power of a power, so that's multiply. So a to the 6, b to the 6. Now the second group of parentheses, the base is negative 4b. So I'm going to keep the parentheses and put negative 4b. I'm going to multiply the two exponents and get 4. Now I have to multiply negative 4 to the 4th power. That is going to give me a positive 256 b to the 4th. Then I'm going to bring down the very first set. Okay, now I'm ready to multiply 1/8 times 256, which is 32. I don't have anything to multiply the a to the 6th with. B to the 6th times b to the 4th is b to the 10th. Okay, here's some problems from the worksheet. Our base is negative 2xy squared. And then I'm going to multiply the two exponents. Now notice this 2 right here is only with the y. So I'm going to multiply 3 times 2 and get 6. Now I have to do everything to the 6th power. Negative 2 to the 6th power. It's going to be a positive exponent because 6 is an even number. So that gives me a 64, x to the 6th, y to the 12th. Number 40, we have 3 sets of monomial. So the very first one is a power of a power. So that's 5 squared is 25, x squared, y squared, put a dot. Now the second monomial, that's also a power of a power. So I have to do each number in each letter. 2 to the 3rd power is 8, x to the 3rd, y to the 9th, and z to the 3rd. Because that's it. The x has an exponent of 1, and so does the z. Times, now the very third monomial, there is not a power outside, so I don't have to do anything. I'm just going to rewrite it, and instead of using a parentheses, I'm going to replace it with dots for multiplication. Now I am going to multiply the coefficients. 25 times 8 times 4 is 800. Now I'm going to multiply my x's together. X squared times x to the 3rd times x to the 1 power. So when I multiply, I add the exponents, and I get x to the 2 plus 3 is 5 plus 1 is 6. Now I'm going to multiply my y's. Y squared times y to the 9th is y to the 11th, plus this y to the 1 power is y to the 12th. And then my z's. I don't have a z in the very first one. I have a z to the 3rd here and a z, so that's z to the 4th. Number 40 in your worksheet looks just like number 46, except for the second parentheses has a negative, but it's very, very similar. You should be able to do number 46. Okay, number 44. Again, that's a power of a power. So I'm going to keep my base, and this is actually a power of a power of a power. So I'm going to multiply all three exponents. 2 times 2 is 4. 4 times 3 is 12. Now that's 3 to the 12th. If you have a calculator handy, you can calculate it. And number 47, the very first monomial does not have anything outside the parentheses, so I'm just going to recopy it. The second, everything is to the second power, so that's negative 3 squared is a positive 9, g to the 8th. And then the third one, now that negative GHJ, remember I told you to put a 1. If you ever have a negative in front of a variable, put a 1, and that really helps. So that's negative 1 squared, which is a positive 1, g to the second, h to the second, and j to the second. Now I'm ready to multiply my variables, my whole numbers together. So that's negative 18, g to the 3rd times g to the 8th is g to the 11th, plus g squared is g to the 13th. Now I'm going to multiply my h. H to the 1 power times h squared is h to the 3rd. And I don't have anything to multiply the j with, so I just bring that over. Oh, I forgot. In the problem, there's a j. Oh, I messed up. That's a j to the 4th. Sorry. So that's g to the 2nd. So that'll make it g to the 7th, h to the 3rd, and j to the 10th. And that is the end of section 7.1.